Hello and welcome to this webinar on monitoring vFabric with Hyperic and Spring Insight. My name's Steve Millage from C2B2 and I'll be taking you through this webinar. So the first thing we're going to do is we're going to talk a little bit about vFabric tcServer, the features of tcServer and what makes that better than, say, Tomcat standalone. So why would you want to use vFabric tcServer over Tomcat? So tcServer is essentially VMware's Tomcat remix. It contains a number of features which we'll go through now, which you can do on Tomcat yourself to some extent, but they come with you pre-configured and pre-built to make things easier for you as an administrator. So first step is we get from Tomcat, from tcServer, we get pre-configured templates. These are standard builds of Tomcat server split away from the Catalina base directory. So what you get is you get your normal Catalina base directory, and then you get pre-configured templates to build new Catalina homes for different tcServer nodes. So these templates are user configurable, so you can change how you build your Tomcat configuration, roll that up into a template, and then reuse it to build 10 tcServer instances from the same template. We'll talk a little bit more about templates later. And the advantage of templates, other than from a standard Tomcat build, is that you get the standard binary installer in one directory, and then all the nodes are separated out. So this allows you to upgrade Tomcat very easily from when patches come out from VMware, or when you want to upgrade to a larger or later version of Tomcat. Another thing that's unique to tcServer is a high performance JDBC to connection pool, which we'll talk about a little bit more later. But this connection pool is essentially being rewritten to remove a lot of contention. So a lot of synchronized blocks are being removed. It's high performance for multi-threaded environments. There's also, within tcServer compared to Tomcat, there are a set of improved diagnostics. So these are tools built into the tcServer instance which help you in the production environment. So this talk is really about production management and monitoring of Tomcat. JMX, again, to help with management and monitoring, is enabled by default. It's allowing you to access all the JMX MBeans that Tomcat normally would expose, and hook up monitoring tools like Hyperic onto these MBeans. tcServer also ships with a bunch of Unix and Windows service scripts, so they can configure tcServer to boot at runtime. There are also another bunch of server management tools, and VMware, when you have vFabric, release latest security patches as binaries, so you don't need to rebuild Tomcat when there's an emergency patch released. You can get these as binaries, update your single binary install, and restart your nodes, and you will get patched Tomcat. And obviously, if you buy the full vFabric, then there is integration with other vFabric components, for example Hyperic, which we'll talk about in this talk. So to summarize, some of the key features of tcServer over Tomcat are the templates, the single binary install, high performance connection pooling. There's also enhanced clustering within tcServer, and there are standard templates built to support clustering, so you don't have to mess around in your server.xml. You basically create an instance from the clustered template. Increased diagnostics, less elastic memory for Java, which again we'll talk about, which is an integration of the Tomcat tcServer JVM with VMware virtualization infrastructure like vSphere. And there's a enhanced management tooling. So one advantage of tcServer really over Tomcat is, one, that it is Tomcat. It's the same Tomcat that you would download from Apache, but it has these extra features really organized and aimed at operational support, operational management, and diagnostics. So what we're going to do now is going to drill in a little bit into the diagnostics, as this talks around managing and supporting Tomcat, the tcServer with vFabric, Hyperic and Spring Insight. So we're going to look at diagnostics. So imagine you're running a large pool of Tomcats. What is there within the tcServer role remix of Tomcat that helps with these diagnostics in production environments? So there is a specific template within tcServer which provides you with some diagnostics. So these enables diagnostics by default. You can see the command up here, tc runtime instance.create. What this does, it takes from a standard template, which is the -t, so it takes the diagnostics template and it creates a new instance of Tomcat. So essentially a new build of Tomcat in a new directory. And the way templates work is that you can specify a number of templates when creating an instance, and they build up on each other. So a template essentially is a bunch of snippets of XML which get pushed during the create instance into your server XML for that instance. So for example, here on the diagnostics templates, what we're going to do is global naming resources. What we're going to do is add a resource. So what this XML snippet does when we run this command is it takes this add resource element and adds that into the server.xml resources, global naming resources section. You can hear what we're doing here is we're adding in a data source factory. And this is the high performance data source factory, along with which also adds additional diagnostics. So you can see here that this data source will test connections on idle, test them on borrow, will run a query to validate that the connection is in the connection pool is still valid, hasn't disconnected from the data source database, and then we run that on a 30-second interval. And we have other settings that we can go into, but another interesting setting is that it's JMX enabled, and there's also a JDBC interceptor, which is going to do some slow query reports on the JMX bean, which we'll dig into in a minute. We'll also add in this diagnostics template, also adds in an additional valve into the engine, Catalina engine. So we can see here that this XML snippet will, when creating the template, will add a valve into the engine, and that valve is a thread diagnostic valve. And the thread diagnostic valve we'll talk about again in a minute. So we can see we had a data source factory. That data source factory is configured to use a slow query report JMX. And we're adding a thread diagnostics valve in here, which has a threshold of 10 seconds for a slow thread. So that data source factory, the slow query report JMX, what that does is when there is a query that goes over the threshold here, which is 10 seconds, then it will issue a notification into JMX MBean. And here we can see these are the notifications that are received by the MBean. This is looking in JConsole. So we have down here the normal JConsole MBean tree. And we're looking at the notifications, and we can see in the notification buffer, these are the bunch of slow queries that we've had over the past few seconds. And we can see from the slow query MBean what the actual query was and the timestamp of the query itself. And any monitoring tool can subscribe for these JMX notifications. And it issues a notification for both slow queries and queries that fail with an exception. So that's the slow query report JMX. So that's part of the enhanced data source. So when you're running queries, you can, in production environment, you can track through the notification buffer what the last slow queries were, and that obviously helps in diagnostics if there are performance issues on the website. Secondly, the second thing we configured in the diagnostics template was the thread diagnostics valve. And what this essentially does is it places into the service request a monitor which tracks the web request. So when an HTTP request comes in, it goes through the Diagnostics valve. The valve essentially acts a bit like a servlet filter, places something on a thread, and tracks data and things that occur within that request. And if there's a problem, it will spit out a message into the log file to say there was a slow query. And this is what we can see in the console output here. So we bring that up closer. What we can see is this was a slow request, and we can see from that what the URI was. So it was booking MVC Spring Hotel Show. It also gives us the query string ID which equals 2, was on part of the URL. Start time of the request and completion time of the request. And this one actually only took 166 milliseconds. So we've specified a small threshold in here. But the other thing the diagnostic valve captures during the request is how many GC collections. So if there was a GC collection occurred within the request itself, then it will capture that information. And it will also capture how long the collections took, whether it was a full GC or a mark sweep GC. It will also capture how many connections from a connection pool it acquired, in this case 1, how many failed, whether it waited for a connection, in this case it only waited 1 milliseconds, and any queries that were run within the HTTP request and how long each query took. So you can see, as you can see, there's a lot of information there, which is very useful if there's a problem on a website. So you can specify a threshold for the thread diagnostics valve, and that threshold, if succeeded, will create a log to cause a log to be generated within the log file, showing you exactly what occurred during that request. As well as that, the thread diagnostics valve can give a bunch of extended logging if you switch extended logging on, which will show you additional information about what's going on. For example, it will tell you the thread, the name of the thread, the priority, its ID, also tell you the protocol of the request. So you can see it's HTTP get method from the local, from which local address and remote port and remote address. So you can work out maybe if there's a problem with certain hosts, remote hosts. It will then also spit out all the request headers that were sent on that request. And in addition, the diagnostics valve will also issue JMX notifications in a similar way as the JD Diagnostics data source does as well. Here, for example, we have a bunch of notifications relating to slow requests. It will send a notification on a failed request or a stuck request, and the stuck is where a thread is spending a long time doing a request. And any tool can subscribe for these notifications, or you can view them in the log files. So just a simple thing as the thread diagnostic valve adds a lot of power in diagnosing what's occurring on a slow tcServer instance. And that helps operational teams triage and narrow down into the problem areas very, very rapidly. So that's the diagnostics features that appear in tcServer. So let's dive in a little bit into EM4J, or Elastic Memory for Java, and what that provides, which is unique to tcServer over and above normal Tomcat. So if you have Tomcat instances running on an ESX or vSphere infrastructure, then best practice for virtualized JVMs is to actually take the guest host and the memory that requires, and reserving 100% of that required guest VM memory in the vSphere infrastructure, so that vSphere doesn't steal some of that memory if it thinks it's not being used and give it to another guest. Then you would tend to tune the JVM heap to occupy the minimum you can, so that to avoid your GC thrashing, you'd want none of the JVM heap to be swapped to disk, and also none of the JVM heap to be stolen during ballooning by the vSphere host. So the best practice is to try to have many small vSphere guests with reserve 100% reservations for memory, and tune the JVM heap to make sure that you have the right amount, but not so much that the heap needs to be swapped out during the guest operating system. So that best practice is fairly well documented, but the problem it has is that you don't benefit from virtualization from memory sharing. vSphere has features where it can take memory from guest virtual machines that are not using their 100% of their allocation and move that to other virtual machines that are a bit memory stressed. So you can't increase the density from a memory point of view of guests on your vSphere hosts. And all the resources have to be provisioned up front. So this isn't obviously an ideal situation. And the reason this occurs, and this is best practice, is that if you run JVMs on vSphere and there is ballooning occurring, then the way the JVM accesses memory is different to normal processors. So memory the JVM hasn't accessed for a long time can be thought of to the vSphere hypervisor as being unused and be moved to another guest virtual machine. This can cause problems when that JVM tries to do full garbage collection and starts accessing memory that it hadn't accessed for quite a while, and then the hypervisor has to go across the cluster of guest virtual machines, try to find that memory, and this can cause extremely long garbage collection pauses. And we've seen it in some vSphere ESX infrastructures of where this is occurring, of garbage collection times in excess of 5 minutes when there's no obvious reason, because the JVM heap is not particularly stressed. It's just that it started using memory as part of its allocation, and then it's going to do a full GC across that memory. So, and this is all because essentially ESX5 allows for transparent page sharing between different guests and memory compression. So what tcServer comes with is something called EM4J, which essentially allows you to balloon memory in VMware vSphere. So if you look at what EM4J does, EM4J is a Java agent. It's started on the command line with the JVM as an agent, and that agent runs within the JVM and actually talks directly to the ESX hypervisor. And what it does is it talks to the hypervisor about its memory allocation, and if it needs to if the hypervisor needs to share some unused memory out of the JVM, what the balloon memory does is it allocates a big block of memory within Java, so that if say your JVM is using, say it has a -X MX of 4 gig, but in reality the normal usage of your JVM is to run bouncing around 2 gigabytes, then the balloon driver can essentially allocate a 1 gig block out of the JVM heap, so that your JVM runs between, say, 1 and 3 gig, and give that back to the hypervisor and essentially mark those pages so the hypervisor can share them or use them across the ESX infrastructure. So what this does is it means you can gain a larger density of JVMs than you could get without the EM4J driver. So as you would previously have to do 100% memory allocation for this 4 gig JVM, so each guest you would give at least 5 gig, then with the EM4J, if each balloon driver hands back to the hypervisor a gig of RAM, then it's possible to not reserve 5 gig outright, but allow the guest to grow to 5 gig if required. So EM4J requires ESX5 and it runs essentially on Red Hat or CentOS. Currently only runs within hotspots. And to get any benefit, obviously you need to be running JVM heaps that are in excess of half a gig. And because the balloon drivers all individually talk, so the EM4J balloon talks directly to the hypervisor, it's not aware of other JVMs that are running on the same guest. So there's a recommendation that you run no more than 4 JVMs per VM. And JVMs themselves should account for the majority of the VM memory usage, because essentially the normal balloon driver has been disabled and the EM4J drivers are the ones talking to ESX. So to switch it on, there are a couple of command line settings for -Ds it's command line settings in the VM. So this is the VM virtual machine, VMware VM. And then in Tomcat, there is a standard template, again, called Elastic Memory. And when you create your instance, you apply that template to that instance. And what that does is it adds an agent -D to the command line, which boots up the EM4J agent. So we know that sounds very complicated, but what the upshot essentially is that you can run a great density of JVMs on ESX if you know that they don't all utilize all their memory at once. So if you're running a bunch of 4 gig heaps, then, as I said before, you can run more of those on the machine without having to do a full allocation for all their memory. For example, like I said before, you would need to create a full allocation for the JVM heap. This time you can allow the hypervisor to manage memory, and that would normally result in a greater density of JVMs. So another part of diagnostics is, if you're running a web application in production, you need to be able to troubleshoot that application. And by troubleshooting, we mean, what's going wrong if there's a problem in the application. And to do that, you really need to know information from the inside the application. For example, how many database calls does the page generate? What was the SQL? How long do those queries take? Why does the page take a long time to load? Which part was slow and what happened? And this is the information. If someone comes to you and says, our website is running slowly, help, then these are the sort of questions that you're going to ask. And what we're going to talk about now is something called Spring Insight, which comes with tcServer. And Spring Insight helps by giving you deep dive information about what is occurring within a Spring application running in tcServer. So it provides information on all the database queries, information on web requests and responses, and component calls and their timings. And it can be used both in development, QA, load testing, and production. It's low enough overhead to be able to use in a production environment and provide diagnostics of slow web requests in production. So Spring Insight works by, again, running an agent within the JVM. That agent instruments code using AspectJ, which is a library for enhancing bytecode within the your Java application. And bytecode enhancement essentially puts probes into your application which gather metrics about what occurs. And these metrics are then sent to a dashboard, which is a WAR file running within your tcServer. And that dashboard renders these results for you to look at, and we'll see a demo in a second. This does slightly increase the memory requirements of your application, and because of the bytecode enhancing, it can increase the permgen requirements for your application, so you may have to change some of your JVM settings. So what we're going to do, this is a canned image, so what we're going to do is we're going to switch to a demo. So if we go to our usual Spring application. You can see here's a standard Spring travel application. We're going to make a few bookings. So let's find a hotel. Taking a while. We'll choose the Marriott in Atlanta. Never been to Atlanta. We'll book a hotel. So first we've got to log in. My session's expired. So we log in. First time's going to be a little bit slow, I think, because it's compiling JSPs. We put in our credit card number. Hit proceed. Oops. How do I put the correct credit card number in? And it needs to be 16 digits. How many have I got? 1, 2, 3, 4. Right, get it right. Confirm the booking, and we can see we booked a hotel. So let's do that again. Let's book the DoubleTree again in Atlanta. You can see when we hit book, there's a bit of a pause. Book it again, confirm, and now we have 2 bookings, and finally we'll do one in Palm Bay. Again, a bit of a glitch when we hit the book hotel button. So now we've done some web requests, and what we'll do is we'd now switch to Spring Insight, and let's just refresh that. So Spring Insight will show us how our application is performing. So we can see our applications on the left hand side. We've got one application called Booking MVC 1, and the different colors basically tell you whether these applications are running fast or not. So orange is slow, yellow is better than orange, and green is good. And we can see here in real time a view of our application health. We can see that there's no errors, but there was some unacceptable application response times. We have a gap. The ones we've been running now, we've got some unacceptable, and then a lot of them were excellent. So this gives you this, so anything requests that are in the red will show you whether your requests were getting slow, and then the green is good. So if we drill down into our application itself, so we split that up, and it will show you the different controllers that were running and their speeds. So we can see that Spring MVC dispatcher servlet response time is 5 seconds, hotel show, hotel search, and hotel list. Some of the response times were 5 seconds, but we can see that if we drill into Spring MVC servlet, dispatcher servlet, we can see the response times. Let's dig into here. So here we have full response times in detail for that servlet. We can see here our throughput. This is how many transactions per second we'll be getting. The blue is the response time trend, so we can see we're up in a few seconds. 95th percentile is 5 seconds, and the mean is 1 second. We've had 20 calls, and 5 of these have been marked by Spring Insight as frustrated. So what that means is we've got greater than 800 milliseconds. Response time, 3 of them were tolerated, so between 200 and 800 milliseconds, and 12 were less than 200 milliseconds. So what we can do is we can drill into this, and we can see the different requests that generated these frustrating times. And we can see that many of them are these get booking hotel ID 2544, all the ones we've just done. So if we dig into one of these, so let's take this one took 5 seconds. So if we click on that, what we see down here is the trace of that one call and where the time spent. So if we see here, we've got a GET request. If we click on the GET, we can actually find some more detail. And here we find a summary of all the things that were basically that we showed in the thread diagnostics valve. You can see that it was a GET request with the hotel ID 5, see where it came from, what the session identifier was, locale, context, all the request headers. I actually have 2 JSession IDs, which is slightly strange, and all the response headers. And then we can dig into the different filters, and we can see for each filter the name and the class, and how long that filter took. So note 0 milliseconds was the self timing, so these were very, very, very fast. We come down here into more filters, and a Spring Web Dispatch, then a transaction on the JVM booking surface, create booking. So if we click that, it's a read-only true transaction, and the status of it now is committed. And then we have a JPA request. You can see that it's a JPA booking service, and then we have this booking process rules, which is a method call, which if we hover over there, that method took 4.6 seconds. But there's no obvious reason why. It did do a hibernate session get, but that took 0 milliseconds, and it did a JDBC select the customer. But again, that took 0 milliseconds. So we can see from Spring Insight immediately that this booking rules, process rules function is the one that's causing problems in our application. And what we'll do is just to validate that, we will look at a different trace. So let's take this one here that took 5 seconds. And let's have a see. There was some time in the Spring Web Dispatch there of 860 milliseconds. Not sure why, maybe a GC pause. But again, we see process rules took 4 seconds. So again, that was quite similar to the other one. We have one here which is slightly different. So what is this one? This one took 2.3 seconds in a render request. So there was more information about that. So that's a different type of request, but it could have been maybe the first one we did. So you can see in Spring Insight provides you very deep drill down information into what is occurring in your application. There's another view which is a recent activity view, and this will show you requests in real time as they come in. So we can see these are our requests. If we make some more searches, do some clicks, there's that pause again. So it works out the rules. Okay, we should be able to see in the Spring Insight dashboard, here's basically our requests have been occurring. So there we had, so we can click on a bar and we can see we had one request for 39 milliseconds. Click on this bar, you can see we had 4 requests in that time box, one of which took 3 seconds. In this time box, which is actually a 15-second time box, we can have, see we had a bunch of requests, all of which were quite small because the bars are down. So these are the ones that you're interested in. These ones took over 3 seconds. There's actually, again, only one request in that time box that took over 3 seconds. All these ones were very fast. So if we click on that one in particular, again, we can go down in the trace detail. Surprise, surprise, our booking rules took 3 seconds. So we know from a lot of information now that this is the method call that is causing us problems. And it's on that source, that class, and it's that method. So essentially we need to now get the code out and look at that method. So Spring Insight is a very, very powerful tool for troubleshooting applications in a production environment. So we go back to our presentation. So this is just essentially, I shall skip through these, as these essentially show us what is occurring in case the demo didn't work, obviously. So the difference slightly here is this is running Spring Insight operations and in these screenshots. And what Spring Insight operations does, it's a centralized server, and all the different tcServer nodes send their Spring Insight information to it. So here we have 2 servers, and each server's health trend, and you can essentially drill down into each server's data as it's gathered. So as we saw, health is good. Look at response times. We can see the response time histogram. In this server, nothing's bad. And we can see, drill down into each different bar to see the methods, and then drill into the actual details of the trace. You can see that query. And then the recent activity bar for a production system. And there's also Spring Insight also integrates with Hyperic, which we'll talk about in a minute. And basically from Hyperic, which is where the operations people may be using, you can get Spring Insight graphs for health and performance. For example, there's health trends and individual response times. So let's look a little bit more about Hyperic. Hyperic is part of vFabric, and it's a monitoring and management solution. Out of the box, the great thing about Hyperic is once you install agents on your host, out of the box it can gather a lot of information rapidly. It can monitor over 75 technologies, and key thing about any monitoring package is, does it monitor what you need it to monitor? You don't want a lot of point solutions that monitor different little pieces. You'd rather have a thing that gives a broad and consistent monitoring across your estate. Hyperic does automatic discovery, so like I just mentioned, if you put an agent on a box, it will automatically attempt to discover what resources exist in that box. And we'll talk a little bit more about resources, but that essentially is what servers, what CPUs, what memory, Tomcats, databases. It goes away and searches for known resource types and attempts to discover them. It also gathers a lot of metrics by default, so once it has attached itself to a resource, it will gather a lot of standard metrics without you having to set them up. So unlike, say, an Agios or something, it's not, you don't have to set up each individual metric that you want measuring within, say, Tomcat for each MBean. You can use, it will just gather them automatically. It can track events such as log errors and raise them up to the console, and it also provides the ability to start and stop Tomcat and other resources like databases, etc. Built on top of metrics, it provides alerting and notifications so that on anything you're measuring, you can just create an alert if a metric exceeds certain thresholds, or in certain combinations, certain thresholds are exceeded. And those alerts can then be raised to the Hyperic console or sent off to operators through emails and other notifications. And it also provides you access as an operator if you need to drill down into the actual running resource and see live metrics. So the architecture of Hyperic, essentially what you do is Hyperic itself runs in a centralized server, and that server accesses a MySQL or Oracle database or in future Postgres. And then within each host that you want monitoring, either physical or virtual, you run a Hyperic agent. And what that agent does is it runs on the host, discovers what's on the host, and then sends metrics back to the centralized server. And when you want to do control operations, the server sends control off back to the agent who actually runs the operation on the host that it's running on. For other devices, for example, vCenter or storage and network devices, the HQ agent runs on a proxy host and communicates with a switch or storage device through SNMP. Within Hyperic, there's a concept of a platform, and the platform has on it many servers, and servers themselves can have within them services. So these are all what are called resources in Hyperic terminology. So a platform is an actual physical host or virtual host, and that, for example, Windows, Linux, etc. Then there are a bunch of platform services, which are CPUs, file systems, networks that it discovers. And then it also discovers different servers on these platforms. Now, servers are processors typically that are running, for example, tcServer or RabbitMQ or MySQL. And then within each one of those servers, it will then go off and find additional services. So, for example, within tcServer, a session manager, a JSP, thread pools, data sources, those are all services. And Hyperic essentially discovers all those for itself automatically without you having to set them up. So we'll dig a little bit into the Hyperic user interface. Again, we've got a demo for this. So if we switch over to that, so we have Hyperic. This is Hyperic running here. I'll just sign out and then sign back in. So you log into Hyperic, and then it comes up with a standard dashboard. Now, Hyperic user interface itself can be a bit busy, but it is very powerful once you can know your way around. And so dashboard is like a little portal into the resources that you have. So we can see here that we have some favorite resources. We have a platform 1055.961, another, and then on that we have a TC runtime called Insight node, which is the one that we've just been running. Then we've got another one which is a MySQL on 1062.202.96, which is actually down, and another tcServer Insight node on 1062.202.96, which is also down. We also have some saved charts here. So these are, this one is the heap free, memory free on Tomcat. So it's a Spring source runtime. So this is actually gathering the JVM heap in real time. And this one here is then switching load average in 5 minutes on the host 1055.961, which is running this Tomcat. And then we've also got on the dashboard any alerts have recently occurred. So we've currently had a slow failed requests and any control actions that have been taken by operators. What I'm going to do is I'm going to drill down into this platform 1055.961, which is basically one we're running our demos on. And this shows you graphs essentially over the last 8 hours of what's been occurring on this host. So this is what we have here in the here we have all the services that are running on this platform and the servers that it's discovered. Okay, so when you install the agent, it basically goes away and finds all these things automatically, so you don't need to set them up. So for example, on the platform we have a CPU. Click on the CPU and we'll see graphs for it down here. So the CPU, idle, usage, system CPU, user CPU. Go back to the platform. We have file systems. Click on the file system. You can see file system stats, disk reads, writes, bytes, use percentage. Again, the metrics are gathered are all, these are default. As soon as you install the agent, you get this data. And it's discovered some network service interfaces, of which the little folder, so we have more than one, so we've got two. So we have ETH0 and loopback, and this is a combined graph of both of those bytes received, transmitted. Again, it does this automatically. We can use this map to go back up to our platform. So these are it's basically a tree view of what is discovered. We can see on this platform it's discovered a tcServer runtime and another tcServer runtime, a sendmail, MySQL stats, NTP server, and a Tomcat, which is running Hyperic, Hyperic agent, and an ActiveMQ server. So we'll go back up to the platform at this stage. And let's drill into the tcServer. So essentially we have a folder of tcServers. It says here that we have a little folder icon, so that means there's more than one in there. So if we drill down into here, we can see we've got two tcServer runtimes discovered. One is Insight node, which is up, and one is Lighthouse node, which is down. So let's go into the Lighthouse node. So that one is down, and we can see that it's been down. These red icons will tell us that that node has been down since 4:59. So we'll jump back out and look at the one that is running, which is our Insight node. And here we see our Insight node that no deadlocks. We see our JVM heap memory, how much percentage of time it's spent in garbage collection, so 7% dropping down to 1. This probably goes to where our pause times we had. We've also got a event occurring here, which is where we started the server again. And we can see our uptime. And we can drill down deeper into the individual garbage collectors, which we've got no data yet. And we can drill into the JSP monitor, which again hasn't gathered any data as of yet. If you go into metric data, you can see what sort of metrics you can gather for results by looking at all metrics. So we can see that these are you can get JSP counts, reload counts per minute, etc. So we drill back up into the Insight node. And we have all these different, so we have thread pools, global request processor, diagnostic engine, module, stats, server monitor, etc. So there's a lot and lots of metrics that are gathered within Spring, within this tcServer application. And we can drill in to get a more detailed graph. And we can use that to see in more detail. We can then define an alert on that. So for example, if you wanted to define an alert on heap usage alert, heap free memory is less than, is less than 10% of baseline, then you can create an alert for that. Priority medium is active, and then that's an alert configured now, and that alert will essentially be sent to a different role. So we created a alert. We can tell that alert to notify different roles. So let's say that notifies the super user. And similarly, you could, from an alert, you can do a control action. So we could have, if it fired, we could on our tcServer tell it to restart. And then if that alert fires automatically, then the the Hyperic will restart the tcServer. So let's go back to our tcServer instance. Go back to our alert definitions. So you can see we already had some alerts: excessive time spent in garbage collection and deadlocks detected. And what we're going to do is show some other things you can do in Hyperic on tcServer. So let's go into control. You can see that if I wanted to, I can restart tcServer. And I could also do it on a schedule if I wanted to. So if I wanted to do evenings and weekends only, I could do that. You can see that it's restarting. probably find that our web application is now broken. Yep, there you go. So Hyperic allows us to do that. Restart the server. That's completed, and we can see a history of who did what in the restarts. So you can see that HQ admin restarted the server at 11:26:631. Sorry, 26:11:631. So it's auditing who's doing what. In addition to starting and stopping servers, we can also configure the server itself. So if we go to server configuration, just try and see that's up. Yeah, need that time to run. Back to here. You can see that from Hyperic, we can set up and configure a tcServer instance. It's taken a while, maybe because my server is dead. And switch back to monitor for a minute to show some of the things it can do, and then when our server comes back, if you can see in the monitor that we have the red dot, so that means that server's down. Again, we can see that all the servers in the TC runtime 6 help are down. Drill into there, you'll see that both servers are down at the moment. And we can see again that Insight node went down at 6:26, and similarly we can also see that there's an event occurred here, and that event was a restart action. So we can see that yes, there was an availability, the server went down, and we can see a reason why the server went down. Maybe if we go back into views in here, again we will see if we can get our tcServer back. Go into application management. So here we can see the applications that are deployed on this tcServer and whether they're running or stopped. So we have two applications running, and we can also, from here, we could, if we wanted to, upload an application WAR file and load them onto tcServer. Within server configuration is where we can set up essentially how the tcServer itself is configured. So if you jump into general configuration, you can set down ports, shut down ports, JMX, authentication, security, a lot of the things you'd expect to be able to set up on a tcServer. So contexts, web application logging, resources. So we've got no data sources in this one. We could create a new data source. So we can do management and control of tcServer through the Hyperic interface. So that essentially is a quick overview of Hyperic. It's a very, very powerful tool. Any resource that it automatically discovers and gathers metrics on, you can create alerts for. If we go back to our platform, you can see that it now knows our TC Runtime Insight node is now available after we did our update, and our application is back running, essentially done by hitting restart within Hyperic. So if we switch back to slides, just to wrap up. So we have some things in case demo didn't work. So the other thing we haven't shown on here is that Hyperic can also do vSphere monitoring. So it has extensions to monitor vSphere. Here's essentially the vendor which you get. You attach it to a vSphere vCenter server, and then these are the individual vSphere hosts. So it changes the hierarchy slightly. So that's a host, and then there's a VM on the host, and then we've got the different resources managed by that Hyperic discovers within that virtual machine. So the resource hierarchy from what we saw before is extended to include a vCenter, and then there's individual platforms, and there's an ESX host, and then each ESX host has individual VMs within that. Other than that, all the Hyperic servers and services within that platform work as you'd expect. So Hyperic itself can auto-discover all the ESX hosts, auto-discover all the VMs running on those hosts, and also detect when vMotion and things like that occur. So it's also a very, very powerful vCenter in addition to monitoring of your ESX and vSphere infrastructure. It can correlate metrics between the host and the VMs running on that host. For example, in this case, we have performance data for the host and performance data for a virtual machine running within it. So that essentially wraps up our webinar, and hopefully that's shown that tcServer has combined with Spring Insight and Hyperic can give you very detailed deep dive metrics and diagnostic information, so that when you're running production infrastructure running on tcServer, that these things provide you as an operator extensive capabilities to rapidly get to the point where you understand what is occurring on your infrastructure and why any problems are occurring. So thank you for listening. We'll now switch off the recording as we switch into a question and answer mode. Thank you.